Hey, Tim, I think we can start.
Okay, ready to roll.
Ready to
Well,
roll.
yeah. Well, good morning, everyone, or good evening, or good afternoon, depending on where you are. My name is
Yeah,
Tim
I
Cox.
think we have some good evenings out there. I see
We
some
do?
international attendees
Excellent.
here. So,
All
yeah.
right. Well, I'm here on the communications team here at Brewity, and I first want to thank you for taking time out of your day for our webinar. If you're new to these webinars, this is the third in our series that takes a look at how artificial intelligence can be used to address two goals in customer care and service groups. One, increasing our efficiency, and secondly, reducing costs. And of course, the reason we're focused on these goals in the first place is to improve customer experience, or CX, in both the home appliance and commercial equipment sectors. Now, in today's webinar, we will look at how AI and machine learning technology can help you by predicting which parts will be needed for an on-site service intervention. And the question might be, well, how does this drive CX? So I have an example for you. Imagine you're a field technician assigned to repair a home appliance, and the call center has scheduled the repair call and you're now on site to fix the problem. Unfortunately, you arrived a bit late because the previous call ran long, so maybe this customer is already a little bit annoyed. But the good news is you figured out what caused the problem and you know how to fix it. But there's a snag. You can't fix the unit today because you don't have the right part on your truck. And of course, no field tech likes the conversation that then has to ensue with this customer. So today, we're going to explain how Brewity can help avoid this situation. We hope you'll leave today's webinar with a plan for how to integrate this technology into your service center, and you're better armed to determine how you can reduce these costs related to parts and boost customer satisfaction in 2021. Little housekeeping here before we start. Please note that the chat channel is open for your questions, so I'll be looking out for those and I'll log them as they come in. Feel free to shoot them in as we go, but we will respond to those questions at the end of the webinar. All right, I've got two gentlemen with me today. We'll be starting with Tom Ian, who works closely with Brewity's home appliance OEMs, as well as our home warranty and extended warranty customers. Tom will kick off by introducing us to Brewity solutions for parts prediction. And then also with us is Andy Chimulgund, CEO of Brewity, who will take us through the underlying AI and machine learning tech. So, Tom, over to you. You're going to set the scene today, and I'm turning things over to you.
Yeah, set the scene, but if you could kick me on to the next slide there.
Yes, sir.
Thank you. And thanks a lot, Tim, and nice setup. So, Tim, parts prediction. I think the ability to accurately predict parts, whether it's what service technicians load on their trucks as they go on service call, or how parts are ordered and distributed to service depots, is a critical factor in the success of a service ecosystem. This is true from both a cost perspective with the avoidance of repeat truck rolls by having the right part for the job, and also having efficient part inventory management. But as Tim was talking about, it's also very true from a customer experience perspective, where service problems that need new parts can be addressed quickly with a single service technician visit by a technician who has the right part. Historically, typically, parts prediction has been done based on service technician experience, okay, and what they decide to load on the truck, or on historical part uses information. For more accurate parts prediction information, for more accurate parts prediction, okay, Brewity uses current and historical fault issues for the specific model type that it be serviced, and has access to the BOM, the bill of material, for that specific model type. For this, Brewity has developed machine learning models for part prediction for specific device types with data sources that include the current, but a large amount of historical data on fault issues and bill of material information from specific models. So coming up after me, Andy is going to describe in more detail these part prediction models, how they're built, how they're trained, their output, and measuring the performance. But before that, I want to put parts prediction in the context of Boviti's broader product portfolio. So Tim, if you could jump on to the next one there. And thank you. Parts prediction is one of a series of products that Boviti provides. These products are used across the entire service ecosystem. Agent Assist is a call center agent product that allows an agent to triage problems with a chatbot and a decision tree, see contextual information about the specific problem from manuals, facts, videos. If a technician dispatch is required, it's an informed one with a service technician giving specific background recommendation and information, and where appropriate, also a part prediction for what to take with them on the service call. Tech Assist is similar in product from a capability, used for triage and for smart search capabilities for specific problems, but often typically delivered in a mobile form factor for a service technician to use. Customer Assist allows for self-service capabilities where customers can look to triage problems themselves and look up product information and so on, okay? Each of these applications can use parts prediction, where part prediction made by a Boviti engine on a fault issue is done in conjunction with a fault triage that has been actually done by a call center rep and so on. So as an example, a call center representative that's triaging a problem where parts prediction is part of the solution will see various parts predictions made as they work their way down the decision tree as they're triaging the problem with the customer, okay? And after Andy, I'm gonna have a demo of this, okay, that will show our Agent Assist with parts prediction enabled. And how is that used to triage a problem, and how parts prediction is part of that solution and changes as we move down the decision tree as a problem is triaged by the call center agent and the end customer, okay? So with that, we also have the Insights product, which is basically a management product. And that can give you an overall view of call center performance, service ecosystem performance, agent performance, but it'll also give you a management view of parts prediction performance as well, okay? So we'll talk a little more. You don't necessarily have to use the Boviti suite of products to have the parts prediction capabilities. We have customers that have integrated parts prediction into these solutions. We have other customers who are using some existing products that they may have had, but are just using us for parts prediction capabilities. And we'll talk a little bit more of that. But with that, I want to hand over to Andy, where he'll give you a kind of Boviti backstage view of model creation, model building, model training, and model performance for parts prediction. So Andy, I think it's time to drive the bus.
All right. Thank you, Tom. And thanks, Tim, for the introduction, and Tom to go through these slides. So let me, Tim, I'm just moving forward this slide. Okay. So what I would like to talk, we will go into the details about what part prediction model means and how we build up a part prediction engine in Boviti Insight. But before that, let me just give a little bit of a understanding in terms of how we tackle the problems and how we envision the entire AI ML aspect of it when it comes to parts prediction. I mean, as Tom mentioned earlier, carrying the right part on the truck and making sure that the truck rolls in only once and then doing the fix at the first time. It's not just required for a manufacturer from just fixing the issue, but it's also very much in part of the entire customer experience strategy. And as part of that, what happens is that there are multiple sources of data that currently the customers or the manufacturers have. This could be for last any number of years where you have warranty claims data, you have appliance form, you have information from service calls, you have information from call center calls where you have actually, all those things are documented. So one of the first things what we started looking at it is that what we call it in the analytics space is that we have to look at it, what is the problem here that we are trying to solve, and whether can we make this as a, what we call it as a supervised learning or unsupervised learning. So in case of supervised learning is where there is a human in the loop. And what that human in the loop means is that you have this information that's coming from historical data, from information that's coming from various sources that has happened quite in the past, but that tells you what potentially can happen in future. So taking that information and actually massaging that information to create the models that will predict what will happen in future is one of the backbone of the Brevity parts prediction engine. So the key components when we start looking at that is it's really how you structure the data and how you structure the data, how you clean the data. And so this is where our ingestion tool, what we have built, is actually used to clean and structure your data. Because from a data analysis perspective, we need data in a certain format, and your data could be in multiple formats. There could be customer complaints in one column, there could be services column, there could be a free text that the call center agent may have typed, and then there could be model numbers, the revision numbers. So there are multiple complications or a way a data is structured inside your system. So one of the first thing what we do is that we take that information and massage that to create a structure that is more friendly from a Brevity's prediction engine, or what Brevity parts prediction engine needs. And then once we structure the data, we do the data cleaning. And part of the data cleaning is really where we actually, like for example, there will be a free text that the agent or the call taker has typed in. So cleaning up that text to just extract information that's pertaining to predicting a part, and taking, because that's one of the most important things when we start building these models. And part of the building the models is that how you build the word vectors, how you build necessary information that's required for you to do that prediction. Once we do this cleaning and structuring of the data, that's when we get into the processing and building the model. And then building these, after the models are built, then that's what gets shown as part of the dashboard, or can be integrated into your a ticket information that goes to the service technician, and multiple ways that information can be shown. And we will get into the details of how we do the processing, as well as how this information get shown to you as a user, as well as third-party technicians, and so on and so forth. There's another aspect of it that I would like to add to this, and this is fairly new in terms of manufacturers. Home appliances have been doing this for the last 3 to 4 years, but overall, commercial appliances and other industries are catching up on this trend, which is the whole concept of the IoT data, or the connected data as we call it. So the concept of connected data is now these machines are actually connected to the cloud or to the internet and pumping a lot of data. And that data is coming into your central system. You have a way to take that data, but not necessarily, and I'm sure there are different BI engines that are seeing this data and coming up with different usage of that. But one of the biggest way what we see is that we could actually take that connected data and we could actually give you parts prediction based on that connected data. And this piece is what we call it as more of a unsupervised learning. And in this case, what happens is that we are just looking at the patterns of the data that's coming in from a connected feed. And it's actually based on the certain patterns, we are actually coming up and saying that, okay, right now the compressor is showing me these vibrations. So this vibrations means that the compressor potentially can go bad in the next 3 months. So predicting what part, and if that happens based on the sound, we could actually tell you that what part needs to be replaced or what part needs to be carried forward. So if that's how our parts prediction engine is designed and used today in the field. So with that, what I would like to go into the little bit of details in terms of how the inner working of these engines are, and then based on that, if you guys have any questions, we'd be happy to answer them at the end of the presentation. So one of few things what we see from this data that comes really from the call centers is that what is the sequence of the events that happens when we collect that data. So typically what happens is that the customer contacts the warranty provider or the call center, and either the call is through a web or it could be a phone call. If it happens through a web, typically a chatbot gets popped up. It could be our chatbot, it could be a third-party chatbot, but the whole information that gets collected from the chatbot is passed over to our prediction engine, which is basically the crux of this prediction algorithms are. So then what we do is that there is a preliminary troubleshooting that establishes that service technician is needed in this case. And this could be done through the what we call it as case-based reasoning, that the call taker or the consumer goes through the bot. And once that is established, then the parts prediction models actually gets kicked in, and it actually starts as the customer is giving the complaint, or as the call agent is typing the information from the customer, our part prediction engine in the background start pulling that information and start giving you the required parts with certain accuracy. And the way our thought process in that is that we provide all sorts of parts with different level of accuracies. And at the end of the call, or at the end of the conversation, you will see a set of parts which have the highest percentage of accuracy, which are most commonly used. An example here I can give you is in a typical ovens in the home, you could actually, a broiler may not be working, and there could be an issue with the heating element of the broiler, or there could be an issue with the control panel of the computer that sits inside the oven. Majority of the time, it's an issue with the heating element, but there is a time for 10% of the time you may see an issue with the control board. So you will see a control board and heating element as potential parts, but heating element with an accuracy of 80% versus control board would see an accuracy of 10%. So that's the way a servicer or a call taker can determine which parts to be provided as part of the requirement. Sorry, I'm just trying to advance the slide. Okay. So now once we get the information from the call taker, what needs to be done in terms of model building, or once we take this information from the old warranty claim data, or all the historical information that what we have collected, we take that information, and that's what is basically used to build the model. And the models that we build are what we call it as the base model, which is a model that will come with the Bruviti's product as off-the-shelf products, which we have built these base models based on the information that we have seen in the public domain about those products. That could be customer reviews, it could be servicers' blogs, or it could be forums that we collect this information from. And all of that is get fed into the building this base model. And this base model gets applied to now your claim data, your warranty information. So now this base model gets enhanced with the model that gets built with the enhanced model that is specific to you with your data. And so typically for a device, it could be a one model, or it could be a multiple models, depending on the quality of the data, depending on the number of transactions that we have collected, and so on and so forth. So here is the process of how we train the model. So the first thing what we do is, now here is the data collection. So here is what we are collecting: all the data, claims, the ticket data, every information that comes from your CRM tool once the call comes in. Then we extract the problem description as stated by the consumer. And this is where wordsmithing comes in. This is where we understand what the words are. And this is where our natural language processing engine comes in to figure out what the problem that the customer is talking about, and what is the relevance for that description of the problem to the part that is required. Then based on that, we extract what parts were used in the past, and correlate that information with the warranty data and the claims data in order to predict it for the future, what we think what the part is required for this particular call. Using that, what we do is train the model and we fine tune the model. When we say fine tune the model, this is where we are actually what we call it as a 80-20 rule, where we build a model on a 20% of data, and then we apply that model on an 80% data as a test case. And we keep repeating this process. And this could be a multifold process where different samples of 20% of data is taken and applied to the rest of the 80% of the data, just to check our model is functioning or not. So this is even before we load the model on the call center's call takers application. So this is in the process of building the model. We were actually tested on the previous historical data to make sure that the model is accurate and fairly satisfactory where we want it to be. So once the model output comes in, then it actually tells you in terms of what, and this is where in some sort of a configuration from the business or from you as a customer comes in, where you may say that the accuracy of the parts prediction engine, what we are looking for is we want you to predict only 3 parts. In some cases, you could say that we are okay if you predict 5 parts, because you know the truck is going to roll out with X number of parts. So we need to know a general information in terms of what parts are needed, not necessarily top-notch accuracy. And again, this could be configured based on certain problems or set of problems, because for example, in a refrigerator, if a compressor is not typically carried by the technician when they roll the truck to the consumer's house, but in some cases, if our parts prediction engine is predicting that there is a problem with the with this particular refrigerator, that the compressor needs to be changed, so then we have to provide that high probability that saying that the part required is the compressor, so the technician can carry that. So typically, the lower probability of the parts that you see are less likely used, and that's how we show that in terms of the dashboards, in terms of the accuracy, what we think, what the engine is telling in terms of what the most likely part that's going to be, and what the least likely part that is required for this particular role. So then it comes to a little bit in the details of how we measure the performance of all these models that we build. So we have a different way of measuring the performances. So we use different statistical modeling in terms of once the model is built. So a classic example here, what I'm going to give it to you is that what we call it as a precision and recall engine. So the idea behind this is that really you're looking for what are the true positives and what are the true false negatives. So that's the data that you're looking for from an accuracy perspective. So in some cases, you will take what we call it as a precision, which is going to tell you the quality of the algorithm. And in some cases, we are going to show you the recall, and the recall rate is going to give you how deep how the algorithm is, how effective that algorithm is. So for example, in this case, if you say that the model predicts that we are going to use the parts A, B, C, D, E, and in reality, parts used by the servicers in the previous calls are probably parts ABC. So in this case, we could predict 3 parts out of the 4 parts that are actually required for this call. So in this case, the accuracy rate of the engine is the recall rate. In this case, what we will use will be 75%. And so once the model is created, various recall and precision rates are calculated, and then the best model that provides the best outcome probability-wise is the one which is chosen for the deployment. Okay. All right. So with that, I think, Tom, back to you for the demo.
Right. Let me just see if I can grab control here. And so normally we would, of course, be probably all in the same place when we're doing these. But
so let me stop the control on my side. Yeah.
Okay. I did a little double fast there. So, I'm just noticing my neighbors, landscapers, have just arrived for their weekly Thursday work, so you might hear some background noise, but we'll go on. So I'm going to run you through a demo, and this is not actually live, but it's actually based on a real interaction with a customer with a particular problem, okay? And I'm going to show you our Agent Assist product primarily, okay? And I'm going to show you an Agent Assist version that is integrated in with parts prediction. So as the problem gets triaged, you'll see the parts that are being predicted, and as there's a greater description of the problem as we work our way down a chatbot and a decision tree, okay? Then the parts that are predicted and the likelihood of those parts being needed will change. Okay, so just going through some really sign in here. In this instance, this is actually a connected product, and Andy mentioned that before. Okay, for parts prediction, we don't need devices to be connected. Indeed, the vast majority of our customers who are using parts prediction are not using it on connected devices, okay? This particular one has to be connected, okay? And I'm pulling up, in this case, real-time information from this refrigerator. On the left-hand side, you see all the associated information, some information about the model that's connected, the wireless network, the error codes some errors that are being seen, and that's going to be the basis for how we actually triage in the next screen using Agent Assist around this particular problem. So from here, I'm going to fire up in the top right corner, Agent Assist. This automatically takes in model serial number information, the actual error code from the connected device in this case, but we always also get this information from things like CRMs that we may be integrated with, and so on and so on. So this is the Agent Assist screen. What you'll see on this, I'll just kind of break it down. On the left-hand side is specific information about, in this case, it's a refrigerator, okay, on the device that's being triaged, okay. We've already been passed some information about this particular product, serial number, version of product, okay, and also some initial information about what the problem is, okay. The agent has access to manual FAQ information that is directly contextual to this particular model type, to this particular problem, okay? And this will change as you actually triage it further and get more specific about the problem, okay? The chatbot over here on the right is what the agent uses to try and triage the problem further, okay? And in this instance, the Agent Assist also includes a parts prediction capability. So as the problem is triaged, you'll see the parts being recommended, and the percentage likelihood of that part being required will change dynamically based on the interaction with the customer, finding out more information and going down in the chatbot, the decision tree to try and triage this problem. So in this instance, it's a water leakage issues, okay? The agent tries to find out more information about where the water leak is coming from, and initially told it's the dispenser, okay? So that piece of information drove the parts prediction to select several parts and get an associated likelihood that part was required to resolve that problem, okay? The agent seeks out more detailed information on the source of the leak, okay? Ice in the door chute could leak down the chute, and then they're just asking if there's any ice around that's blocking or forming around the outside of the chute, okay? The answer in this case was no, okay? That answer also dynamically changed. If you look at it, the percentage likelihood of the parts, sorry, difficult to be, not hit the advance button and backward button twice, but you see as we go down the tree and as questions are answered and we get more details about the problem, okay, then the parts prediction values change and the likelihood of that part being needed to solve the problem. And then there's a further question to kind of get more detail about where the leak is coming from, that air in the water line could cause water to drip from the water dispenser. Do you see droplets forming at the tip of the water dispenser or the tip? Well, the answer in this case is yes. And that yes answer, again, if you look, changes the dynamic of the percentages of likelihood that that particular part is needed to address or solve this problem. Okay, so here we talked before, if you remember when I talked about agent assist, tech assist, customer assist, each of those products that can have a parts prediction capability. Okay, more relevant, I think, for the agent who's working with a customer who's calling in. Okay, so this information about the parts, okay, and other information about what the specific problem is, okay, is sent to a service technician that then gets informed of that information and this part prediction, and then will, I think, address what they'll take with them on the service call accordingly from both a parts point of view and be armed with information about specific data about what the actual problem is. We also have a tech assist problem, and some of our customers are more set up in an environment where they don't necessarily have a call center. Okay, a tech gets a call out on their own, and they do some triage in advance of the dispatch on the particular model that they're dealing with, on the particular issue that they're dealing with, for them to make an assessment of what part is going to be needed. Now, as I said before, this one shows an actual integration with our agent assist, which is probably what the majority of our customers do. But multiple of our customers are just using our parts prediction capabilities. They may already have some existing products that they're using to triage the customer's issue, okay, and are using our parts prediction, with our models that we provide and that we built, often adding in some of their data around fault history and specific fault issue that we'll make a part prediction on. So you can use part prediction kind of integrated in with our agent assist, tech assist, and even customer assist suite, or you can use it on a standalone basis as well. Okay, but here you see, I think, a very powerful suite of tools that, first of all, provide you a whole bunch of contextual information about a particular problem from facts, manuals, and videos. Has a chatbot that allows the agent to triage the problem. And in this case, with integrated parts prediction, you see this, you saw in the demo, this dynamically changes as the triage becomes more detailed and we get a more specific understanding of what the problem may be. The recommendation changed on the percentage likelihood of which part is actually needed. Okay. So I'm just going to move on to the next slide. Yeah, so this is based on a case study with one of our very large OEM customers. And the thing I want to kind of call out here, I think that the thing about parts prediction, particularly when you're dealing with truck rolls and more efficient truck rolls, in the case, I think, of parts prediction, being able to resolve the problem on the first dispatch by ensuring that you have the right part for the job on the truck. Okay. In this particular instance, and this was an OEM that had their own W-2 employed service technician workforce. Okay. They saw with our part prediction capabilities, by reducing repeat truck rolls, okay, an overall reduction of truck rolls by 13%, okay, and with that, considerable savings for them in their overall warranty costs and servicing costs, okay. The other ones here are, just talk to our, abilities from one, an agent assist perspective, that the AI we're providing and in the chatbots and the decision trees there, okay, allows them to get a first time complete. That is, in this case, is a measure of them being able to resolve a call from a customer on the phone in a single call, okay, without obviously having service dispatch, without a second call as well. And self-service and the ability, and this is sort of a newer thing for some of these customers, but I think younger demographics, like this, from an engagement perspective as well, that we've made available to them the triage and knowledge base to their customers that where the customers may want to actually try and triage and fix a problem themselves, at least initially. Okay, this has led to a lot of call defection from the call center, and really a very successful kind of success rate for people who are actually using this. But this has gone from zero to a considerable amount of people using this because of the capabilities that we were able to help them to introduce to customers to allow them to have self-service capabilities to triage and try and fix the problems themselves without calling the call center initially. Okay, so the one thing I want to kind of say, a couple of other things around parts prediction and its cost benefits. In this case, we were dealing with an OEM that had their own employed service technicians. Okay, and had to some degree a tight range of products. Okay, that they had a lot of experience in it, and their service technicians had a lot of experience in it. Okay, but even in this case, and I think that even if you're getting parts prediction better, even by a few percentage points, okay, in this type of environment, it leads to considerable savings in terms of truck roll reduction, and obviously with that, overall better customer satisfaction. But I think the value of parts prediction is even higher in some other environments that we go into. Okay, we deal with sort of people who have, say, home appliances in service, okay, that use a third-party service contractor network. Okay, so I think the challenges for them around parts prediction is that, one, they're dealing with a broader suite of vendors and product types. Okay, and their knowledge about that equipment is naturally diluted. So having something that gives them a parts prediction capability greatly increases their efficiency and reduces their costs. Okay, and I think the other thing that if you're dealing with this sort of environment is that it's not just a matter of the two things that goes on. I think very often you get a service technician visit initially that's almost investigatory. Okay, they make no attempt to sort of come with the right part, or they come with a very low likelihood of having the right part. So you not only get necessarily a second truck roll, okay, but often cases, I think that if the part prediction is totally wrong, we see a lot of instances where people will go with a part and install it, okay, but it's not the right part to rectify the situation at all. But it's compounded by not just the fact that you come with the wrong part, the wrong part actually gets used and installed and ultimately charged. So I'd say even in sort of OEM environments where this is sort of an example of that, where the service infrastructure of that environment is sort of very knowledgeable about the product, probably has their own service technician workforce. We can show good improvements in that, but I think it's even more compounded of a value if you have a diversified install base of products that you have to support. Okay, say in the home appliance space, multiple different vendors, laundry, ovens, refrigerators. You've quite a diversity of install base that's under service contracts with you. That the benefits of parts prediction there are even more pronounced, and then they're further pronounced if you've got a third-party service operating network that will often go with the wrong parts, or will often maybe install parts that weren't the actual ones that were needed to rectify the problem at all. Okay, so I'd say the same is always true. From a vertical perspective, I would say specialize in the extended home appliance space, okay, and in the commercial food equipment space. But I think in that market as well, the commercial equipment space, there's probably a large suite of products that have to be supported from an install base and service perspective. Okay, in some cases, products that they have somewhat limited familiarity with or don't see that often. Okay, so providing some element of parts prediction to those products with the models which we can provides a big upside and benefit to that environment also. So I kind of want down on the kind of commercial benefits of parts prediction, because I think they're really strong from both, you know, a cost savings perspective, and obviously from an enhanced customer experience perspective as well. Okay, and I think particularly pronounced if you're in an environment where you maybe have a diversity of equipment in your install base for service, and if you operate a third-party, you know, service network, there are more challenges with that in current environment without capabilities like parts prediction to make them as efficient as possible. So that was the last slide, Tim. I think we got a couple of questions, right?
As a matter of fact, we do. Let me just see here. Okay, question number 1. Let's see, where's our Q&A? Tom, let me just...
Sure.
Well, we don't have a Q&A slide. Never mind. We can do it without a Q&A slide.
We'll just call it the Q&A.
This is the Q&A slide, everyone. So let's see. First question. Do I need the entire Bruvity product suite to take advantage of part prediction capabilities?
Yeah, yeah, I think just I'll repeat a little what I said there. I think you do not, okay? I would say most of our customers who are using parts prediction also use our Agent Assist or our Tech Assist product. But we have, as I mentioned, you know, companies that have, you know, maybe their own solution in that space, okay? Or wanted to start immediately with parts prediction, where we've offered a standalone parts prediction capability that allows them to predict parts without necessarily using the rest of our products. So the answer is no, but I think, you know, we offer really compelling capabilities with Agent Assist and Tech Assist and our full suite of products that parts prediction can integrate into. But you don't necessarily have to take all them to use parts prediction.
So I would like to add a little bit on this from a technical aspect of it. As Tom, you correctly pointed out, in terms of it's not required that part prediction needs to be used with other Bruvity products. But one of the things I can say that from a proof of concept perspective, and a lot of people when they start working with us, their Agent Assistant, the other products may require some integration into your CRM, into your call center, and so on and so forth. But parts prediction engine is one thing where we can just get a dump of data from historical calls, and you can just say, okay, here's the data. Can you go through this data, analyze this data, and come back and tell us what you think, what the parts are required? And that can be something that can be easily proven from us, and then the rest of the pieces from an integration perspective can be looked into. So this is always a way where it's independently can be looked into, as well as can be purchased as a standalone product.
Okay, all right. Next question. How would you integrate Bruvity part predictions with our internal part ordering system?
Yeah,
Well,
so
go ahead, Randy. Why don't you talk to that?
Yeah, so this is again depending on how your part ordering system is created today. In some cases, you have some enterprise backend system that's been that you use in order to catalog the parts and pro. So we do an API level integration into that. So that's how we actually, in cases where you already have pre-existing part database. In certain cases where you actually use third-party parts warehousing, where parts are not necessarily stocked or a part of the data lake that you have, but it's something with the third party, then we do again API level integration in order from an ordering perspective. Some of our customers actually also take our parts prediction engine from a scheduling perspective. They need to integrate that into their scheduling, when to schedule the technician based on the availability of the part. So it all depends on what kind of backend system that you have. Today, we support all known cloud providers in terms of integration, whether it's Amazon, Google, SAP, Salesforce, in terms of integrating into the backend, or Oracle.
All right, good. Similar question, I suppose, Andy. How do you acquire the BOMs, or bill of material information, for the equipment that we'll be servicing?
So this is something that, again, the manufacturers do provide this as part of the data integration aspect when we start looking at the data ingestion tool once we start integrating into their backend system. So again, the BOM, but for our base model, we collect this information from publicly available parts catalogs that are available online. That's where we pull this information from. But with the manufacturers, again, this is something that we integrate with your internal engineering drawings, as well as internal systems where the BOM part comes in. For home warranty, extended warranty kind of companies, we actually do that based off of the base model. And then depending if they have that information, then that gets integrated into their backend. But otherwise, it'll be based off of our base model, based on publicly available part data. So
Gotcha. A couple more. Let's see. I think first we should talk about Joe Fissette. He's interested in hearing more about how the self-service module works. For example, for self-service tech support.
Yeah, so I'll answer it a little bit on technical side, and then Tom, you can talk through it, what we do. So this self-service tech support model, what we have, what we call it as a customer assist, and the way it has been designed, that this actually gets, when a consumer comes on your website with certain questions, for, let's say, for an appliance that they're trying to figure out whether it's an issue related to my, like, for example, a dishwasher. Actually, it's there is a leak in it, so I need to find out whether there's something wrong, or there is some leak in the pipes that are connected. And so I'm coming in and actually asking this question on the website. A chatbot pops up, and the chatbot is actually goes through the case-based questions. Again, these are all AI driven. So depending on the input that the consumer is giving, the rest of the questions and the relevant answers will start popping up. This is something that we have deployed it today with OEMs, as well as home warranty, extended warranty companies, where this, we call it as a level 0, or a first level of support before a consumer makes a call to the call center and tries to, and the idea behind this customer assist is the self-service tech support is to really try to resolve the issue without the consumer even calling the call center. And if the consumer does call the call center, then we also have a ability for a handoff where the tech where the chatbot actually can collect that information and hand it off to the agent, where the agent can pick it up from where it was left off on the chatbot.
Tom, you want to add to that?
Yeah, there's a couple of instances where, I mean, the end customer could be, for example, QSR, quick service restaurant or something like this, that is trying to triage a piece of equipment themselves before, a call to a service technician or whatever. Okay, but it's typically, from a form factor point of view, it looks like a chat bot, okay, that you saw on the agent assist screen. Okay, in certain cases we provide some other contextual information around facts and manuals, okay, with customer assist as well. So the form factor is often used on mobile. Okay, so although it's typically on a website, a lot of our users, this are actually at home on their mobile phones using the chatbot, and we'll have support or a built machine learning model for the particular piece of equipment that they're trying to triage, and that model will drive the behavior, the decision tree, and the triage based on what they're inputting. So it's I think demographically, in a lot of cases too, the younger demographic often prefers to try to use this as sort of a first level of engagement when they're trying to have a problem, rather than say being on hold with a call center and so on. But it's also, I think, got pick up to be used by in some commercial environments by a restaurant trying to resolve a problem with a particular piece of equipment first, before looking for a service technician dispatch.
Good. This is a more general question, I think. So what does an engagement with Bruvity look like? For example, do you offer a pilot install so we can ascertain how it will work, how Bruvity will work in our environment?
Yes. So we typically, and Andy can, compliment on anything. Our typical engagement is that, we'll offer basically a free pilot, okay, that'll allow you to assess the products, and, see their benefit and see their value, okay. In the home appliance space, we kind of recently announced a service pack for home appliance, so that in a cloud-based solution, we have support for all of the major home appliance vendors and their major products, either laundry, refrigerating, cooking, and so on. And that's a cloud-based solution. So just providing you a login, okay, you can immediately start using that, okay. Ultimately, some of our customers want this to kind of be integrated with their CRM and more directly into their flows, but they can start using it immediately and assessing the value of it, okay. For pure parts prediction, I mean, often our initial proof of concept is that if they want to only look at part prediction, we gather some data that they may have fault identification, but specific and historical. If they've got some of their own chatbots, maybe pull in chatbot information for that. And then we look to kind of build a part prediction model for them, probably on certain initial pieces of equipment or certain vendors and stuff like that. So I think our engagement is one that's, easy to stand up, okay, pretty frictionless, okay. And we feel like 60-day period, we can show you, real value for this, from all our products, from agent assist in terms of, quicker, better triage, from parts prediction, much better accuracy in what parts are being predicted for the ecosystem they may have from a depot and parts distribution perspective, but also from what gets on the service technician's truck.
Yeah, and to add to Tom, your point, for our pilot process, we don't even need detailed integration. So a lot of times our customers in the past, before they signed up with us, had just sent us a dump of CSV file. So just an Excel file or a CSV data dumps that tells us, okay, here is the last year's service calls. Go take a look at it and come up with what you think is the parts required for these type of calls. So that's how typically a pilot will run. Just the CSV data is all we need before any integration happens.
Let's see. I don't have any more questions. Tom, I know you had a couple of, if only someone would ask this questions. Anything like that you want
to? I sort of got most of them in, I think.
Very crafty of you.
I wanted to kind of highlight, a couple of things, from a benefit perspective as applies to parts prediction. I think, OEMs, even though that they might have, a tight number of products, a very well-trained and experienced service ecosystem, including their own service technicians, they can see benefit of this, okay? But when you get into an area where you have a broader range of products that are in service and that you have to support, okay? Or you're dealing with an environment where you have third-party service contractors, that environment is even more set up for benefit for parts prediction. But in the OEM case, if you can move the needle on better performing parts prediction even a little bit, cost savings are really, really large.
Mm-hmm. Well, let's see, we're at almost the top of the hour here. I think probably, unless there's anything else to discuss, are we concluding?
I think we can conclude, Tim. It's getting actually some of our attendees are
lunchtime
up pretty late. So
yeah.
This, this will be recorded, and we'll send out, details to the attendees of the recording. So if they want to pass it on to some of their colleagues or other people that they think would be interested in this, there will be a recorded version of this. And, feel free to, reach out to us if you want to, discuss our solutions more, both from a parts prediction perspective, but from a broader service suite perspective as well.
All right. Well, I guess it remains to say, take care, stay well, and happy holidays.
Okay.
Happy holidays, guys.
Yes.
Thank you.
Thank you.
Thank you.